So this is the example for the volume dispensed by 2 dispensers for hot drinks. As you can see in this example here, I've highlighted some of the key points that are important. They've done a lot of the work for you already. There's not much calculating to do in terms of from the data itself. They've already told you the N for sample A and sample B, 10 and 13. They've also told you S, the sample standard deviation, for A is 3 and for B is 5. And the sample mean for A is 124 and for B is 132. In the question, they're also telling you the 5% significance level is what they want to use, and that they are testing for no difference in the variability. So all of that we can use in our answer. If you can print off the blue boxes, they will help you. You don't need them, but obviously remember that in the exam you won't have them. So these are just a guide to help you while you are learning. So what are my variables? I have an A variable and a B variable. So I'm going to say let A be the volume dispensed from dispenser A, and shockingly let B be the volume dispensed from dispenser B. So I'm just letting the examiner know I know what I'm talking about in this question. Hope you can see that. So my H0, as always, is that mu A equals mu B. And in this question we're being asked to test that there is no difference. So if this is that there is no difference, then not equal to B, not equal to mu B is that there is a difference, and that's what I'm looking for here. Not equal to means that it is a two-tailed test, and as I've stated in the question, it is the 5% significance level. I don't have to work this out. They've given me the mean from A, and they've given me the mean from B. My mu is unknown, and that doesn't matter because I don't actually need them, because I'm assuming that they are equal in my hypotheses. So when I do the subtraction, I'm actually saying that they're going to be 0. In the question, I'm actually given the standard deviation as 3 mil. For my formulas, I need the variance, so just be careful here that you do 3 squared and 5 squared. And don't leave them as 3 and 5 because that will trip you up and mess up all your calculations. And my n's are given in the question as 10 and 13. So I've already been given most of the information. I don't actually need to do a lot of calculating up to that point. From here on in, however, I need to do a little bit more work. So the critical value needs to be a t value. We haven't really looked into degrees of freedom much for this hypothesis test. I did point out that on your pooled variance, the denominator of that formula is your degrees of freedom, where V is NA plus NB minus 2, which is the same as this take away 1 and this take away 1 added together. So for this question, it is 10 add 13 take away 2, give me 21, which means if I look up on the T tables, there's some old ones that might look slightly different to what we are used to. It is a 5% two-tailed, so I'm going to 0.975. And we have just worked out that our V is 21, so if I go down to 21, 0.975, 2.080. And because this is a two-tailed test, it is plus minus what did I say? 280? 2.080. And that's my critical value. Now my test statistic I can't work out without a pooled variance, and rather than messing up the blue boxes, I want to try and keep them as similar as possible. I've added a little pooled variance up here. We've obviously been doing this over the last few lessons. This is NA minus 1 SA squared plus NB minus 1 SB squared all over those degrees of freedom, NA plus NB minus 2. And if I put in all my values for my pooled variance, I have 10 minus 1 times 3 squared plus 13 minus 1 times 5 squared all over 10 plus 13 minus 2. Putting that in my calculator, press the fraction button, brackets, 10 minus 1, you can put 9, that's fine, times 3 squared, you can put 9, plus 13 minus 1 times 5 squared, all over 10 plus 13 minus 2. I've put it in exactly as I've written it in the formula. Obviously you can make it a little simpler for yourself, and that gives me 18.143 if I round it. Now I have my pooled variance, I can use that for my test statistic. Again, I'll write out the formula to remind you. X bar minus Y bar, or in our case, X bar A take away X bar B, take away mu X, take away mu Y, which, because we're saying that they are the same as each other in our H0, that will always be 0. All over your pooled variance that we've just worked out, times 1 over NA, add 1 over NB, and I square root that denominator. Now I know this bit catches some people out with their calculators, so again I will write out the numbers, what we should be putting in, and then I'll show you how to do it on the calculator. So 124 take away 132 minus 0, because they are equal, all over 18.143, 1 over 10 plus 1 over 13, all square rooted. On your calculator, start with the fraction button and type in your numerator 124 minus 132, and I'm going to add the 0 for good measure. Then on the bottom, start with your square root, then 18.143 bracket fraction 1 over 10 plus fraction 1 over 13 bracket. This bit on my calculator now looks exactly like this does on my sheet. That gives me a value of minus 4.465, and that is my test statistic. I can now compare and conclude, as I have done in all other hypothesis tests so far. Draw myself a little diagram so I know where to accept and where to reject. My critical values from earlier in the question were a positive and a negative 2.080. And my test statistic is negative 4.465, which is somewhere down here in the bottom tail. I accept in the belly and I reject in the tails. So this is a reject H0. My H0 was that they are equal, they are equivalent, they are the same. So I'm saying that is not true, they are not the same, but I need to use as much terminology from the question. So therefore, there is significant evidence to suggest So I'm saying that there is a difference because I'm saying that they are not equal. A difference. I'm going to use the words from here. In the variability of the volume dispensed by the two machines. And there is your answer. Obviously a lot more work than what we've been doing so far for this one, so it will be worth more marks, although they gave us a lot of values to start with, so that does help us out.